Okay, so my name is Mark Menzies. So I'm a security engineer for Checkpoint. So it means I'm relatively technical in there. I'm not a salesman. We're responsible for basically our Scottish customers in here. So today we're going to have a quick talk about AI in cybersecurity and the way that we deal with AI. It kind of follows on quite a bit from, I'm going to say, almost every other presentation this morning already. Certainly following on from Jamie. So if we have a look, we've got some rather distinguished people who have been talking about AI, been telling us about it. So Stephen Hawking, development of full artificial intelligence could spell the end of the human race. All right. Steve Wozniak, telling us in there that computers are going to take over from humans, no question about it. And then we've also got Elon Musk. It's going to be the cause of World War III. And finally, Vladimir Putin. The country that leads in AI development is going to rule the world. Okay, so these are rather bleak, doom-filled thoughts of the future. And just as Jamie Graves was mentioning there as well, AI is still in its kind of infancy. And we always think of this kind of thing happening to us. But it's not as bad as we think. It's not necessarily that bad. The one thing that we can't ignore, though, is that everybody is talking about AI. This is an entire event on big data, and the only way of dealing with processing big data is always through AI and the ability to try and automate or mechanize as many processes as we can. AI is with us, and it's been with us for quite a while. There are billions of dollars invested in AI tech. Now, as you can tell, it's most of the vendors in here, most of the other organizations, we're all using AI to varying degrees. We're all, as consumers of digital services, we are already using AI as well. If we think of it as AI is effectively the next industrial revolution, and this is where we can look at things as to say, are we really ready for it? Are we not? In the 18th century, there was the first industrial revolution. So they were looking at replacing muscles with machines. They did this because machines didn't get tired. Machines were more accurate. They could often work faster. They could often work harder. They didn't stop for breaks. They didn't strike. You didn't have to feed them. You had to put fuel in them at times, but that was about it. So there was a big thing in there of the Industrial Revolution and how it changed the way that we do things as a culture. We're now looking at the next revolution, where we're replacing brains with machines. So when we're talking about replacing the brains with machines, it now means that we're now trying to mechanize and repeat what people are doing normally in their jobs. But we're doing it faster, we're doing it quicker. We've got the ability to scale much wider than we have for individual humans. And it also means, and therefore, using machines, it's more repeatable, it's more consistent. We've already seen all of this. People already use it. When you sign into Amazon and almost any other online retailer, you're always going to be presented with, here's some suggestions. You looked at this. You might find this interesting. And it's not the only place that does it. There is lots of places in there where we're surrounded by AI, by, I'm going to say, relatively intelligent algorithms based on the information that they've got to give you some predictions or some assistance. We've advanced to a state in there where we can detect different types of photographs, for example. This is a particular set of photos where we type in cakes. It manages to pick them out. Even the one at the bottom, it looks like a dog. We don't necessarily need to go and start tagging all our files, all our pictures with specific criteria. The algorithm itself is clever enough to go ahead and start looking for them. We've got speech recognition. Almost every house has something that is smart and can understand your voice. We've got Siri, we've got Cortana, we've got Alexa, we've got smart TVs. All of these things in there, we can have more or less a human-like conversation with them now. We can ask them questions and we will get, in the main, an intelligent response, and it will kind of fit. But this is not the only thing that we've got. We're also at the stage now where we've got things like robot doctors. You put in your symptoms online, and it'll go away, carry out a quick search, and say, if you've got this, this, and this, it means you may have that. We've got legal firms, insurance firms now using AI to base their risk analysis for claims and insurances. And we're also looking at robot lawyers that can help you do certain things. So the AI that we're continually to consume is getting bigger and bigger for us. So why is all of this thing happen now? AI is not new. AI is something that's been being developed and being researched and being looked into for a number of years. But why is it now getting to the stage where we can start to consume it? There's a couple of different technologies that needed to evolve, needed to advance to such a stage where we could actually use them. First one is storage. We can now store terabytes, petabytes of data, these data lakes, with minimal cost now. I'm saying minimal cost, it's much less than it was 5 years ago. So we can now store and record all of this information. There's also been advancements in compute. We've now got the ability to reuse multiple compute farms, cloud-based, DC-based, wherever it is. We can now start pulling together resources to crunch your numbers. And then we've also got the mathematics. This has also improved over the years. Certainly in the last kind of 4 or 5 years, and there's been massive leaps in the algorithms that people use for AI. So it's now becoming more and more accessible to organizations, industries, and business. It's now no longer just the sole responsibility of academia with our massive data farms. So all of these things have led to the point in there that the use and the acceptance of AI is becoming more and more common. So is AI magic? Okay, we're looking at this and it's like we put a question in and it suddenly picks out all the pictures in there with cakes in it. Is it clever? Is it magic? There's an example here. When we think about AI, we need to give it data. We need to give it information and a certain level of parameters to say, this is this answer, this is that answer. And from there, it learns. It starts to evolve. Anybody heard of T-Bot? Probably not. It wasn't really a glorious success for Microsoft. A couple of years, they released an AI-based bot, a chat bot for Twitter. And they let it loose on the internet. And it was out there for several hours before it started tweeting like this. Now, I am not going to repeat anything that's up there. But is this a problem of the AI? Not necessarily. It's a problem of culture. This is what people were saying to it. It was responding in kind. All it seemed to learn was profanity and racism. Not necessarily great. So after several hours of this being printed off, Microsoft pulled it. Okay? They learned loads from it. Potentially the case in there that it's not quite ready. But it gave you the idea of what we could do. There's other things in there that AI can be confused with. This is from Google Translate. Is anybody familiar with the Turkish language? I wasn't until this. The Turkish language in there is a gender-neutral language. It can't distinguish between he and she. And it normally says the letter of, the word of O in front of it. So when we put those into Google Translate, this is responses that we got. So she is a cook, he is an engineer, he is a doctor, she is a nurse. And there's a favorite one down the bottom. He's happy, she's unhappy. So there is definite gender bias out of this. Is this the fault of the Google engineers? No. All the Google engineers did is they fed the algorithm with all the information, all the text that they could find. That gender bias comes from us. Us as users. This is what we are putting out there. So this is not necessarily a bad idea, but it's also not the best. So there are flaws, there are difficulties with AI. So AI is not magic, but it is useful, okay? So what do we need for a good AI solution? We need data. You hear everybody talking about it. Data lakes. We want all the information that we can get. So it needs to be lots of data, it needs to be rich data, it needs to be useful. It needs to also be able to contain all the context, all the information that we need to understand the problem. It doesn't work as well if you're dealing with something in isolation. It needs to encompass everything. Then we also need expertise. We need expertise in AI technology. So we need somebody that's got smarts to go ahead and start writing all of these algorithms, all of these mathematical equations that can go away and pull all the right information together. So we need those guys. But we also need the domain expertise. So in our picture of cakes, we need somebody that can understand digital photography to be able to teach the system, this is a cake, this isn't a cake, this is a toy, this is a piece of fruit, and then letting it learn itself. We can also think about the speech recognition. For something to recognize speech recognition, you need to have somebody that understands speech patterns and the ability to detect different accents, different terminology, different dialects. For example, all of us in here will speak English, but we'll all speak a slightly different version of English. And we need to be able to train these things to do so. So we need these domain expertise. And when we're thinking about cybersecurity, and we want to introduce AI into cybersecurity, then you need to have somebody that understands cyber threats. So when we think about AI being used in cybersecurity, we ask the same question again. Is it magic? Nah, it's not magic. It's not the same as before. So if we're thinking about AI in cybersecurity, it's the same thing of AI in general. We've got a problem of data and expertise. Our particular problems are we don't have enough data and we don't have enough expertise. But we are getting there. Access to the data is a problem for us. So accessing the cybersecurity training data is limited. If we think about what's real cyber data, cybersecurity data, it's information about your attacks, about the threats, about the types of information you've seen, where it's been seen in your network, what happened. A lot of that information in there can be seen as company confidential. And most organizations are not necessarily keen to freely allow that information out. So your smaller startups, your smaller organizations can find it difficult to build a large enough data set for this. Then you've got the point in there we can obfuscate. So we can anonymize the data as much as we can. But if you obfuscate it to death, the data becomes next to useless. So what do you need with this? So one of the answers to this is to make sure that you've got a large enough organization that's trusted, that can anonymize the data where it can, but still make sure you've still got enough usable information out of it to make a difference. The verdict logic is obscure. AI algorithms don't explain themselves. You put some information in, and it will give you a yes, no at the end. It literally is a computer says no. And it doesn't always explain. If we think about, when I was at school doing mathematics, you always were asked, show you're working. An AI algorithm doesn't tell you. So this is often a binary decision getting out of it, and you don't often know why. And then finally, we can have a high false detection rate. This is something that affects all AI. It's something in there we need to be aware of, and we need to be able to mitigate it. If we think about the pictures again of the cakes, there's no big deal for us if we put in a search for cakes and it threw out a couple of pictures of an ice cream cone. No big deal. We can still filter it ourselves and we say, that's fine, I've got all the right information. But when it comes to cybersecurity, getting a false positive, or more importantly, a missed positive, a missed detection in there, that can have a very real, very big impact on an organization. Within Checkpoint, we're doing what we can to pull all the information together. So we've got all of these different sources coming in to our online cloud-based nastiness database. Okay, we call it Threat Cloud. So this is where we're pulling in all the inputs in there from sensors, IntelliStore, malware research, security community, security event analysis, and security analysis and search. All of those are the good things. But everything that we've got within our security portfolio, we input it all into the one. So we cover off quite a bit of this. We've got lots of data. We've got rich data from all over your network. Like some of our competitors in there, because it's where there's very rarely do we have any true innovation in the security field. We're all kind of doing the same thing. Checkpoint's all about our security consolidation. So we've got the security solutions that covers your endpoint, covers your cloud, covers your data center, covers your network, and covers your mobile devices. If we've got the input from all of those, then we've got this rich information. For the domain expertise, yeah, we've been doing this for a while. So we're getting good at this. And we've got, I was quite surprised with this when I found out 6 months ago, was that Checkpoint's got over 400 own internal researchers looking into malware, looking into attacks, looking into threats. So we've got all of this information coming in together. So it's not magic, but again, it's very useful. So if we think about here, AI is revolutionizing cybersecurity. If you think about 5, 10 years ago, everybody was talking about make sure you've got a firewall, make sure you've got antivirus, make sure you're logging. And then we found out that we're getting too much information, and we just ended up turning off logging because nobody was looking at it. So we had SIEMs, security incident and events managers, doing some analysis on this. Is that enough for it? No, not really, because we're now not being able to understand what all of these other different things are doing. We're now in the stage now where we can actively replicate and mechanize a lot of things that security analysts do by trade. So the ability for them to go in and follow this path, to follow this investigation. Where was the domain registered? Was it domain registered by the same guy? Did he register multiple domains at the same time frame? Did he use the same lexicographical format when he was registering these domains? That type of follow-up in there that a good security analyst will do. Find a thread and pull on it. So we're now seeing that AI is certainly changing the way that all the security vendors are working. So within Checkpoint, we've got a couple of things that we do, and we think we do them quite well. We've been using AI, and specifically in some of our threat prevention and threat detection feeds in there for a number of years. And we've been enhancing them and moving them on for the last few years. The first one I'm going to talk about is our campaign hunting. So this is predictive threat intelligence. So this is mechanizing what a traditional analyst can do. We can find and detect a particular threat, a particular element that is malicious. We'll look into invest that. We'll do what our traditional human-based analysts would do, but just automate it and scale it as much as we can. The things like that we're doing is the same thing I was mentioning about the domain. We'll look at the domain registration. Who registered it? How many was registered at the same time? Were there any patterns in the way that it was created? Because it's reasonable for us to look at it and say, if there was one domain that we found to be malicious, that was hosting malicious content, and there was another 20 domains, for all intents and purposes, look exactly the same, then it's reasonable for us to say, yeah, they're all attacks. We're going to add them in to our threat feeds. We're going to block those stuff at source. So what we get out of this is we expose some unknown command and control in malicious domains. We're attributing various attacks to certain campaigns that we can detect, and then we're going to enrich all of this threat intelligence for predictive campaign stuff. This helps us out. This is now, rather than looking at the 0 day or waiting on something to happen, we're now starting to detect things in there that were unknown, that we've never seen. This is a particular small graphic in there about some of the numbers in there when we introduced campaign hunting. And as you can see from there, the red line goes up and down. But at the moment, over 10% of all the threats that Checkpoint detects is due to our campaign hunting AI engine. So over 10% of the attacks that we create, that we recognize. The second one is an engine that we call Huntress. So from this one in there, we're looking for malicious executables. Now, detecting when an executable was malicious or not is one of the hardest things to do in cybersecurity. Because by default, executables are out there. They're meant to do everything, meant to do anything. How do you tell when something's doing something wrong or doing something nasty? How do you know when it's doing something malicious? The good thing for us is that most attackers, most people that write these malwares, these executables, they're often lazy or efficient, as some people would say. They don't always write their own code. They'll do a lot of reuse of code. If they're not using the same code in there, they might reuse the same logic. And as they're using this same particular logic, is that they're now detecting that, well, we can now detect that certain applications, if they work in a certain way or using a particular set of code, then it's malicious. How do we do this? We do all of this in our sandboxing scenarios. So we send everything off to the cloud, and we poke it and prod it, and we detonate it. We are gathering information on all the system API calls for everything in there that this application is doing, and we're analyzing this to say, is this nasty? Is this good? So when we apply this machine learning to reach a verdict in there, and we go into a continuous feedback loop for continued learning, from out of all of this, we're now detecting 30%, or over 13% of all the malicious executables that Checkpoint detects is due to Huntress. So we are now actively detecting a lot more malicious files before they get a chance to even go and activate. This is useful to us. This is useful. The final one we're going to talk about is Cadet. This is context-aware detection. Okay, this is something that we are starting to roll out as a separate feed amongst our threat cloud. So what do we mean by context-aware detection? If we're inspecting an individual element or an individual component in isolation, then we'll get one set of results. Well, what we can do in there is look at it in the wider picture. Now, as I mentioned before, with Checkpoint in there, we've got this consolidated security outlook, where we apply the security over your network, your cloud, your data center, your endpoint, and mobile. Because of all of these things, we can get a bigger picture on the attacks going through your system. So instead of just looking at an individual element in isolation, we can see how it affected the rest of your network. So if we think about, there was a malicious file on an endpoint. How did it get there? Okay, he downloaded it from a website, right? How did he get to that website? Was it an email with a malicious link, or was it an SMS sent into him and he clicked into it? Was it a malicious domain? When was this domain registered? When was it created? Who registered it? Was there other similar domains out there? So all the things in there that traditional security analysts in there would be doing themselves, we are mechanizing this as much as we can. But all adding it in there with the context-aware detection, so we're matching it in from the information from all over your network, not just one place. So if we look at the full context in there, we get these thousands of discrete indicators. We're pulling them all down into one to get one accurate verdict out of it. And if we think about the numbers that we've got for this so far, we're now missing half the detections that we did before, and we've got a 10-fold reduction in the false positives. We're getting more and more accurate when it comes to these things. Now, does this mean that we're perfect at it, we're the best? No, of course not. We're all learning, the same as everybody else that's working with AI. As AI and the technologies and the algorithms and the mathematics behind them, and the ability to log and the ability to normalize these logs in such a way that you can understand everything. These are all going to enhance, these are all going to evolve, and we're only going to get better with it. So within Checkpoint, we're all about practicality. We've got to try and make sure that we're putting something in that is safe, it's not going to cause too many issues, and is also going to work. If an AI engine is too noisy, you're never going to deploy it. If it also needs manual intervention, manual approval, then you're never going to deploy it. You've also got to make sure it's accurate. You've got to make sure that there's fewer false positives, or even no false positives. If you've got an accurate verdict, you can get a practical prevention out of it. So within Checkpoint, this is all about the intelligent use of AI technologies, with all their limitations, with all the caveats. And just to say, when it comes to prevention, Checkpoint's the one for you. Thank you very much.